Hey, hi everyone, welcome to Code Type Management. So, in the last lectures, we have discussed about the transaction management, the commit process, rollback process, and then how the programmatic implementations we can do, the declarative implementations we have done. Okay, so in this lecture, we will mainly discuss about the propagation and before that, I will discuss some fundamental things of transactions also. So, like the transaction management encompasses the supervision and handling of errors and processes that may occur during the transactions. So here I'm giving you one analogy. So here allies one user wants to pay the rent to her landlord, Sarah. So she sends a request to the server side business logic, and the business logic then queries the database. Okay, and do the process. So ask like, hey, Alice, like wants to pay rent to Sarah. So could you decrease the balance of Alice's account by $100? So suppose Alice has the $500. So if $100 will be reduced, it will be like $400, right? So we will do this process via business logic, right? Now this process results in a transactions being created for the payment. However, at some point in the transactions, perhaps like in T4 or T7, some error occurs. So that indicates like Allies has already paid her rent, and unfortunately, the business logic cannot update Sarah's account balance accordingly. So, for examples, Allies had this $500, $100 now reduced. She will have this $400, but the $100 is not deposited into uh, Sarah's account. Okay, so in this critical point, the business logic requires the transaction management actually. Okay, so it must decide like whether to roll back the entire transactions and undoing the changes or commit the transactions. Okay, confirming the changes made so far. So that's why the transactional annotations suppose came. So Spring manages these transactions, have provided annotations. So these annotations can be defined on the classes or methods that I have described as well. And in Spring Boot, transaction management doesn't require a configurations, but in Spring, it requires a configurations. Okay. So the thing like transactional, then propagation type is suppose required. This suppose came into the picture. But these transactions don't just happen quickly. Okay, so to do that, to facilitate that, we need something. So that is the aspect oriented programming. So AOP effectively separates these cross-cutting concerns from the core business logic, like those logging things, then error handling things. Okay, those things will be done in separate. That's why AOP done this cross-cutting concerns. So in typical in-layer architecture, which includes the presentation layer or API layer, business layer or service layer, data access layer or repository layer. So cross-cutting concerns are usually defined within this business layer. So these concerns encompass aspects such as security, validation, transaction management, logging, performance optimization, and other related processes. So when Ally sends the request to the server-side payment method, which was already declared as the transactional method, interceptors come into play and process either before or after the business logic for transactional annotations. So that's why that at the rate before, at the rate after, at the rate around, those things are also there that I have covered during our AOP programming lectures. So here you can see like before or after those things, some things happens. So that things are being happened through the proxies. Okay, so it is our main method. So before or after of it, that proxy is being processed. So this proxy is nothing but the dynamic proxies. That means it creates the proxies at runtime. So these proxies are generated for objects marked with the transactional annotations. So whatever objects marked with the transactional annotations, So for that, actually proxies are being created. The dynamic proxies are being created. So when a method with these annotations is called, so it interrupts the natural flow and allows the processing of additional business logic either before or after the main business logic. So the proxy controls access to the original object, enabling the process either before or after the main object. So like example here, so suppose typically the application includes one service that named as the category service, okay, so which has a create method, okay. So category service IMPL and the proxy that is created by the Spring in runtime that basically extends this category service interface. So this service is wrapped with a proxy, which means the proxy manages access to the real object and implements some business logic either before or after, such as rollback or commit transactions. So Spring creates these proxies in the runtime, what basically means if the application doesn't have an interface, so if application lacks an interface, it will directly call the raw create raw category service. Okay, it has this create method, and the solution is straightforward. The application context extends the proxy directly, and it will just includes only a concrete class, which is the category service, and the proxy simply extend this category service, right? So here I have done these implementations like we have this interface which has this create method, and in the inside this category service IMPL that basically implements our category service interface, and inside that we have this create method, okay, and inside this we are just printing this category service, okay. So in the same way, now proxy category service that also implements this category service, and inside this proxy category service we have printed this proxy category service, and inside that we are overriding this create method. What we have in this interface we are just overriding here, and inside that we have the try block. If that will be succeeded, then we will do the commit, okay. So this here you will get this commit transactions, and if some process fails, then we will do the rollback, okay. Clear? Now we have the test class as well, and here also we are calling the create method, okay. Now, so to do that things, actually we have the some propagations. So what are these propagations? There are several kinds of propagations. We have the required, requires new, then supports, then not supported, never, mandatory. These 6 to 7 types of propagations we have. So why we need those things? So this required and propagation, suppose you can see the structure. This inside this transactional annotations, we are giving this propagation as the propagation required, and inside this create method we are just saving the product. So when it is required, so suppose in instance, suppose you have the 20 lines of data, okay, but on the 18th line your application throws an error, and the transactions calls the rollback functions. So it requires the most usage type. So here, to save the before things, we need the required. So what it does, so if parent transaction exists, we need to use it. Otherwise, we will just create the new transactions. So see like how it works. So when a method marked with the propagation required is called, so if a transaction exists, the method joins the current physical transactions and it becomes the part of the existing atomic unit. It doesn't create the new one. So if no transaction exists, then Spring starts a brand new transactions for this method. So key characteristic is single atomic unit. So if you have the method A required, okay, calling method B, the both actually do the in the same transactions. If method B fails and throws an exception, the transaction is marked as the rollback only, meaning method A cannot commit even if it catches the exceptions. Then logical versus physical. So while there may be multiple logical transactions, one for each method, they all map to the physical database transactions. Most common, it is the standard choice for service layer methods where you want to ensure the all database operations succeeded or fail together. Next is requires new. So when this required new actually come into picture, so requires new is the propagation type is significantly useful for most cases. So if a session is initiated before the requires new, it suspends the previous session and creates a new one. So see, so suppose some parent transaction have already there. So it basically close that transactions, it creates a new transaction and parent resumes after completion of it. Okay. So requires new is about the independence. So it is the reset button for transactions. When a method marked with propagation or requires new, so some transactions if exists, then it just closed it and new transactions started. Okay, new session started. And when that session will be done, then the parent session will be again start its process. Okay, so when to use, suppose audit logging, you want to record that a user attempted an action in the database, even if the action itself fails and rolls back. So email or notification status tracking that a notification was sent. So yeah. Next is support. So supports is the go with the flow propagation level. So it is essentially passive. So like if a transaction exists, so it joins that transaction and behaves just like required. Okay. And if no transaction exists, so it executes anyway, but in a non-transactional manner. Okay. So the difference between the required and the supports is like in the required, suppose if no transaction exists, then it will create a new one. But supports what it does, it will just do the go with the flow. It will not create a new one. It if there is transactions, then it will just joins with that. If there is no transaction, then no new transactions will be created. Okay, so read only for the read only methods, like methods that primarily fetch data and don't necessarily need a transaction to function but can benefit from the being part of an existing one. So for that process, like L1 cache, sharing the same persistence context, for those things we require those. The optional atomicity, so when a method is called from both transactional services where it must be atomic, and non-transactional controllers where performance is preferred over atomicity. Okay, now it is not supported. Not supported means, so when method marked with propagation not supported, that means if a transaction exists, Spring suspends that transaction, the method executes entirely outside of a transaction context. Once the method finishes, the suspended transaction resumes. So if no transaction exists, the method simply runs normally without one. So supported and non-supported, basically both. Actually, if no transaction exists, then it will go with non-transactional manner. Okay. But if some transaction exists, so supported one joins with it and non-supported one close it. Okay. It actually close that one and just go out of the transaction context. And when that method finishes, the suspended transactions resumes. So when to use not supported, suppose you are calling an external API, okay? You don't want to keep a database connections open or transaction open. So in that case, suppose it will require. Never, never means like when a method marked with the propagation never is called. So when there is a transaction exists already, so Spring will immediately throw an illegal transaction state exceptions, illegal transaction state exception. It refused to even attempt to run the code. So if no transaction exists, the method executes normally. So never means, so if it will get any transactions, it will throw an exception. Okay. And mandatory is like if the transaction already exists, then this method joins seamlessly, just like a required or supported. Okay, if no transaction occur, it's there, then then Spring will throw an illegal transaction state exceptions. Okay, if there is no means mandatory means it should have one previous transactions. If it will not find any transactions, it will throw an error. Okay, then error handling, since it uses the existing transactions, so if this method fails and throws an exception, it will mark the entire parent transaction for rollback. Okay, so that's all. After this, I think it's clear to you the propagation things. In the next lecture, we will discuss about the isolation. Okay. So do like, share, and subscribe as much as possible. Thank you.